Welcome to Study Loop.
Hello, today we are going to solve a physics problem. In this problem here, we are given the motor of a table saw rotating at angular speed equals to 3,450 revolutions per minute, and we are told it is attached to another motor shaft, and we have a second pulley that has a circular saw blade with a diameter equals to 0.208 meters. We are told to find the speed or the linear speed at which the operator is rotating the piece of wood with the linear speed, and the other variable we are trying to solve for is the radial acceleration we have. So we need a couple of concepts to solve this problem here. The first one is angular speed omega, and the second one is radial acceleration r. So when we talk about, when we talk about the angular speed omega, we have the relationship that relates the tangential velocity vt to the radius and angular speed as this relation here, vt tangential velocity equals to r times omega, where r is the radius, omega is the angular velocity. And we know the radius is can be written as d over 2. So this relationship here can be written as based on the given variables in the problem. We are told that the diameter of the second pulley is half that of the first pulley. So in that case, we can say the angular velocity of the second pulley is twice of the first pulley. So we are going to have this relationship here, Vt equals to 2Rw. And for the radial acceleration, this is given by AR, there is no square here, AR equals to Vt squared divided by R. So once we get the velocity Vt from here, we are going to substitute it and divide by R to find the radial acceleration. So the two equations that we have here are the equations we are going to use to solve this problem here. The first part of the problem, we are told to find the linear speed of the wood. And we have the equation Vt equals to 2R omega. And we know that R is d over 2. So we're going to substitute in the equation. So we have 2 times d over 2 times omega, and then we're going to substitute with the numbers we have. We have the diameter equals to 0.208 meters. Here we have divided by 2, and omega equals to 3,450 revolutions per minute. So we have this here, revolution per minute. And in order to convert from revolution per minute, which we have for the angular velocity, to meters per second, which is the units of the linear speed, we have to multiply by 2 pi radians divided by 1 revolution, and multiply this by 1 minute divided by 60 seconds. So once we carry out this multiplication, we are going to get V equals to 75.1 meters per second. So this is the linear speed of the wood that we have. This is part A of the problem. Now, for part B, we are told to find the radial acceleration. And if we recall, the radial acceleration AR is given by VT squared divided by 2 divided by R. And we know that VT is 2R omega and R is D over 2. So we can substitute with that in this equation here. So we are going to have AR equals to 2R omega, and here we have squared divided by R, and this is equals to 2 omega squared times D over 2. Now the final step is just substitute with the values we have for omega and D. And here we have 2 times, let's write this down here, 2 times omega 3,450 revolutions per minute times the diameter, which is 0.208 meters divided by 2. And again, as we did in the previous part of the problem, we are going to, in order to convert from revolution per minute to meters per second squared, which is the units of acceleration, we are going to multiply by 2 pi radians divided by 1 revolution times 1 minute divided by 60 seconds. And we have the squared here, so we have it here as well. And once we carry out this multiplication, we are going to get A equals to 5.43 times 10 to the power 4 meters per second squared. So this is the radial acceleration we have here, and this is the linear speed we have. And this is everything in this problem here.